It must be that everybody wants to learn a lot about worms today. All right. So for our regular class, afterwards we'll have our student presentation, and then we'll keep on with class material. But first, I'd like to introduce Bernadette Williams, also known as Bernie. She's been with the DNR for 6 years. She is a forestry specialist, forestry health specialist, and also she works as works in conservation. And she is, I would say, she has to be Wisconsin's worm expert, because I have seen her out in the field, and when we pull up the worms from the ground, she can identify them all, and it's really, really impressive. And she can just take a look at the forest floor and tell you whether or not there's worms invading that forest, which is really cool too. So please give your undivided attention to Bernie, and get started. Thank you.
Thank you, Shannon, for inviting me. So I have had bigger crowds because I work in forest health, so I've talked to all 458 of our foresters, but I'm sure they aren't going to be as excited about this as you are. So let me ask you a quick question. How many of you think earthworms are native to Wisconsin? Wow, I'm impressed. So they're all invasive?
Yeah.
Okay, I like interaction, so I'll pick on a lot of you to answer these questions.
Can I double check that this on?
Sure. Am I on now? Okay.
It says green.
So at the DNR, I work in forest health. So forest health, when you look at the health of the forest, I know, are any of you going to be foresters? No one? Are any of you going to be biologists? Okay. So I specialize in soil invertebrates. So when I walk through a forest, I'm always looking down. So eventually, and I'm older, I was done with school before any of you were born, but eventually I'm going to be that old lady with a big hump because I'm always looking down. I'm getting neck problems because I'm always looking at the dirt. So we'll move on with worms. So Charles Darwin studied worms for over 30 years, and he came away saying that they are the most incredible animal out there. And they are. They have such an influence on any type of environment in which they're found. And when you look at them, they're far more advanced than we are. Can anyone tell me how long they've been around? Anyone want to take a guess? You're young, it's the middle of the afternoon. Even I had to have some candy before I came to wake up. Anyone want to take a guess? All right, so they've been around for about 700, 800 million years, give or take a million. So they're among the most ancient of terrestrial animals, emerging Precambrian, so that's huge. And when you look at them, how long they've been around and how long they've been influencing the soil and where they are, it's really incredible. It makes you feel really small because we really don't have much influence on the earth. So they're pioneers of colonization. Wherever they go, they prepare things in their path. So how many of you have been out on the farm and dug up and you see all those worms? Okay, so you've all, and you've all thought they're good because you said you like to farm, right?
Well, that's what I do, yeah.
Okay, so you're a farmer, so you like worms, right? I like worms too, okay? So they've been around, they're ubiquitous to the entire world except to really dry regions. And the same would apply in Wisconsin. So when you go up into the sandy outwash glacier plains up near Bayfield County, you really won't find that many of them because that sand won't provide proper habitat for them. 7,000 worldwide, so we estimate there's over 7,000, and they find new species frequently. They fall into 18 families, so they're really advanced. And when you look at this particular slide up here, you can see we didn't come on the scene until, right around the glacier. We haven't been around that long. And the reason I tell people earthworms aren't native to Wisconsin, you have to look at the glacial, what happened here. So you look at Wisconsin and it's pretty flat, don't you think? I mean, I'm not from Wisconsin, and I came to Wisconsin and I said, oh my, why is it so flat? The glacier moved through. So the glacier moved through and it took Wisconsin down to bedrock. And the reemergence and regeneration of all of our native species occurred without the presence of earthworms. So this is a glacier, And when you take a look at this, so you see this, it's almost like a tension line. And when you follow earthworms and you start looking into the history of them, you always follow that glacial tide moving across North America. And we could have native earthworms within Wisconsin. They would be in the Driftless area. Studies have been occurring since 1985, and we've yet to find a native North American earthworm here. And generally, the earthworms that you're familiar with, they outcompete any of the native earthworms that would be found in North America. So, can you identify the 3 functional groups of earthworms you see in this particular slide? We divide them up into groups because they live in different habitats of the soil. So they fall into, we randomly call them epigeic, endogeic, and antecedent. So when you take a look at this slide, the epigeic, they're always going to be the litter dwellers. They're always going to be right there, right on the surface, right underneath that leaf ball. The endogeic are always going to be in the topsoil. So they'll be there, and the interesting thing about that, when you look into soil and you're digging it up or you're doing an extraction, they're always going to be sort of gray. They're going to be like this milky gray. So you automatically know, oh, well, that's an endogeic species. And then, does anyone have a favorite earthworm? Oh, come on. Everybody has a favorite worm. I mean, there's 7,000 to choose from. They can do really cool things. Anyone? I'm going to pick on you again because you're a farmer. Do you have a favorite worm? Isn't there one that jumps out at you like you're like, oh, that's my favorite worm?
I have an unfavorite worm.
Okay, well then I don't want to go.
It attacks my strawberries.
Oh, well, all right, so that's a different one altogether. So my favorite worm, they're the antecedent worms, and that's the nightcrawler. So the nightcrawler is one of the most incredible animals you will ever encounter in the world. And it's this lowly worm, and everybody thinks, oh, it's just a worm. This worm can do things that it will never be able to do. How far do you think it can tumble down? Quite a ways. Give me an estimate.
The waving point.
I know you're thinking right there in the back. You want to say something?
Who?
You.
I don't think, no.
Okay, just give me a guess. You were some.
I would say
lowly
probably getting down towards the bedrock, you know.
Bingo. They can go down to bedrock. So we've done cores where they've actually gone down 20 feet. That's incredible. I mean, when you think of an earthworm and you think of its ability to tunnel through all of that soil, through the mineral soil, through all of those layers to get down to bedrock, that worm needs respect. So basically going through quickly, epigeic, right on the surface. There's going to be a quiz at the end. Then there's endogeic, topsoil dwelling, and then the big bad boy, night crawlers, terrestrials. They're at the subsoil going down to 20 feet. That's our farthest core that we found yet. And I suspect they can go farther. Earthworm ecology is really, really cool. Okay, so they eat dirt, they process things, their nature is recycling. So, and they can be too good at their job. They feed in the soil layers. And so when you look at this particular worm, I've been with worms for over 10 years now. If you were to look at a worm, do you think that every one of those segments, so it's segmented, it's an annelid, it's breathing through its skin. Do you think each one of those segments has a specific role it plays? Yes, and that is really cool. So when you look at a worm, and we can talk about earthworm reproduction, and have you ever picked up a worm and you get that slime on you? Okay, so that slime is nitrogen, but that slime is also part of the reproductive process, which is so cool. So, and we'll get into the sex too, because that's really cool. But if you were to look at this worm, and you were to look at those segments, and if you were so inclined and you were really nerdy like I am, you would count each one of those segments. And I could tell you, picking the specific type of worm or species, I could tell you that that slime, it's almost like a hula hoop, has to roll back over to segment 38, which is back here, then roll forward to segment 27, which is over here, and then roll back forward again to segment 31, then roll back again, and where does that cocoon come off? The head. That is really cool. And this particular region in here is the cotellum, so that's the saddle. So everything in there that's happening with a worm is concentrated in that area. How many of you have ever heard that if you cut a worm in half, you have two? Okay, not true. Okay, if you cut a worm before the clitellum, you'll kill it because the head is up here. If you cut a worm after the clitellum, it'll be fine, but that tail will die. So only with 4 species of worms does it occur, and they're all found in New Zealand. So it's a misnomer. Forget you ever heard that. Really cool thing about earthworms, and my boss always yells at me at the DNR because sometimes I give garden talks and gardeners really don't like this slide. But they're promiscuous polygamous hermaphrodites, and some can reproduce parthenogenically. So that is the coolest thing in the entire world. So it doesn't need to do anything. But wait, there's a new worm on the scene. So currently in the state we have 21 European origin worms that all come from Europe. And we recently found the one that comes from Asia. But this is really a cool earthworm. It can reproduce parthenogenically. So it's called the Amites. It's the crazy worm, it's the snake worm, it's the Alabama jumper. It has a lot of different names. When you pick it up, it'll jump, or it'll slough off the back of its tail. Its tail, its clitellum is really milky. It won't have the slime to it. It'll be really smooth. So 4 to 8 inches long, darker than most earthworms that you'll encounter. Skin is glossy, light and smooth, very active. It will jump out of your hand. Moves like a snake. Loses its tail when you handle it aggressively, and it's parthenogenic. So out of the 10 species worldwide, this is one of the parthenogenic earthworms that we now have in the state. So I tried to make a really cool rhyme for you because you're all college students. So no sex please on the fees. So anyway, that's my joke for you. It doesn't need sex. That's the thing about this particular worm. And the population that we found it in Madison. We actually found it on the UW campus. You walk into this forest and it's a forest like you've never seen. It looks a lot different than a forest that has regular European invasive earthworms, completely different. We suspect this population has only been there for 3 years. When you do a soil core of this particular area, because this worm is so aggressive and so quick to reproduce, there's 6 inches of just sheer organic matter there, only in 3 years. So you have to core down 6 inches to get to the mineral soil, which is huge. There's no regeneration. There's no seedlings. There's nothing. And when you pick up this soil, it literally will just pour through your hands. So it's like nothing you've ever seen. So it was really exciting to find, but it's scary because this is poised to enter our forest. So when you look at an earthworm and you look at the effect on the soil, when you go out into the woods and whatever you're looking for, if you're looking for soil invertebrates, if you're looking for snakes, if you're looking for herps, turtles, salamanders, all these different things, they live on top of the soil. When you look at what Wisconsin used to look like, it looks completely different. But when you look in an area of Wisconsin, if I get a forester that calls me and tells me, I think I have a real earthworm problem in this particular area of the state, I'll say, well, tell me where you are, tell me the county, send me a map. And I can look at that soil and I can pretty much get a good idea of what's growing there, what type of soil is there, and whether or not I should go and take a look. And that applies to a lot of people that work in my field of forest health, because you can look at that soil record and it'll give you a good indication of what's going to be growing there. When you look at earthworms in your forest, they have a huge influence on that soil. So your soil is constantly changing when you have earthworms in there because of the burrowing, the casting, the feeding, the mucus secretion, the death and decomposition. So when you look at the old forests of Wisconsin before the worst invasive species arrived on the scene, who's the worst invasive species of them all? Anyone? Anyone?
Humans.
We are. Wherever we go, we cause death and destruction. Okay, so we are the worst invasive species out there. We caused all of these problems because we wanted to explore. We're a lot like an earthworm. We wanted to explore, we wanted to go out, and we wanted to find new places. So changes again to the physical and biological. mixing the soil profile. When you mix the soil profile, it's going to change how things grow. It incorporates organic material, so on a farm, you want a lot of worms because it's moving the soil. But in a forest, you don't want a lot of worms. It causes a lot of erosion, it allows for water infiltration, erosion, aggregate formation. It also changes the micro-community, so it'll change what's living there on the soil surface. It'll change what's growing there. Have any of you encountered garlic mustard yet? Okay, so garlic mustard, I'm big into all invasive. So when you have earthworms, you have invasive species. So you have terrestrial invasive species. A lot of these species go hand in hand. When you have one, you have the other. Soil effects, I'm big on soil, so just a nice picture of the soil. The layers of the soil, again, you always want distinctive profiles. And this is what happens to a forest. So this is a slide that explains earthworms in a nutshell. So if you were to go out and, right around here you have the central sands, so you could go over to Washera County, Portage County, Wapaka, see a lot of red pine, white pine, red oak out there, and you'd still see distinctive soil layers. And you'd walk into a forest, and I work on a private forest out here quite a bit, and I always am looking at the leaf litter, and I take a lot of soil cores out there. And so when I take that core, I want these distinctive layers to be there. And the main thing that I want to see when I'm walking through a forest, how many of you walk through a forest and you kick up leaves? So you kick up all that leaf litter, you want a dense layer of that leaf litter in there. Unfortunately, when earthworms move in, that duff layer, that leaf litter, that rich, almost like a skin to the soil starts to be consumed by the earthworms. So you get a forest that starts to look like this. And this is really important. How many of you have walked into a forest and you start to see trees that almost look like they're walking on the soil because you can see the root structures? How many of you have walked into a forest and it looks like a green lawn underneath? Okay, okay, all right. Great, so you know what I'm talking about. Does that look like a healthy forest? No. Because you want, what do you want in science? You always want what?
Diversity.
Diversity, diversity, diversity. When you get earthworms into areas where they do not belong, you start to lose diversity. And it'll be drastic. You'll have nothing. You'll have monocultures. You'll have compacted dry soil. You'll have blurred soil layers, so your soil profile is different. And the main thing when you look at this slide, so you can see that the earthworms are blurring the layers, but they're also moving down into the bedrock, which is huge when you look at an earthworm. They change the nature of their environment to suit their survival. They're going to be here a lot longer than we're here, and they've been here a lot longer than we've been here, because they change the nature of the environment to suit their survival. That's one of the biggest things that I always tell people to think about worms. They are really tough, and they change how things are because they're adapting. Okay, so this is your quiz. Is this a healthy or unhealthy forest? Feel free to call out. Why is it unhealthy?
It's not very much leaf litter.
Right. Well, there's not a lot of leaf litter, but does anyone see this? What is that? It's not a grass. What is it? Sedge. Very good. I'm impressed. All right, you get the gold crown today. This is Pennsylvania sedge. Sedge is a native species, and if you're interested in sedges, we are the sedge capital of the world. We have over 300 species of sedge here, and sedge geeks come from all over the world to look at our sedges. And if you want to try an ID sedge, you always have to try an ID when it's blooming, because otherwise it's extremely difficult. Easy, just roll it between your fingers. It has edges. Sedge has edge. Grass won't have an edge. So it's a quick, easy trick for you. This, if I were to tell you, can you see all the worms in here? Anyone see them? You're going to try this when you get home, right? Okay, so come up here. We'll have interaction. So if I were to say to you, wow, you see all of those worms in there, could you pick any of them out? And I see them. Does anyone else see them? They're all over. You don't see them? Okay, well, I'm gonna make you an expert. Okay, so see this pile? See this pile? See this pile? See that pile? See that pile? See that pile? See that pile? There, 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 there. You know what those piles are? What do earthworms eat? Oh, what do earthworms eat? What do earthworms eat?
Decomposing plant matter.
Well, they do. But if you were an earthworm in a hardwood stand up north, so say you were in the American Legion State Forest up in Vilas and Oneida County, and you were really hungry, what would you be eating? And what is your favorite food? What season are we in?
Organic matter.
What season are we in? We are in organic matter, but I'm going to get you to this place. Or in, you know, you've all raked your leaves, right? You've all raked your leaves to the curb. When the leaves start to fall, the earthworms feel the vibrations of the leaves hitting the forest floor. And their favorite leaf is, anyone? What's our state tree?
Maple leaves, sugar.
Sugar maple leaves, because they're loaded with carbohydrates and sugar, and so they consume those. And how many of you knew that an earthworm, how does an earthworm pull that leaf? How does it eat it? How many of you like butterflies? Okay, so how does the butterfly, well, it rolls out that really cool proboscis and it goes into the flower, pulls out the nectar, pulls out the pollen. An earthworm has a proboscis too, so it rolls out that proboscis, grabs onto that leaf and pulls it down into its borehole. And so when it's done eating that leaf, it pushes out the leaf petiole because it doesn't want anything to do with the leaf petiole. So you're all going to be miniature earthworm experts when you're done with this. Walk and look for these little piles that will be pushed up in the soil. Look for those leaf petioles. That's an earthworm. And do you know what earthworm it is? You can tell what type of earthworm it is just by the leaf petioles and the mittens and everything. I won't get you to that stage, but anyway, I can do that. Anyone know what earthworm that would be? It's my favorite worm. Were any of you paying attention? The night crawler. So that's the terrestrials that can do that. Pennsylvania sedge has a relationship with worms. So many of you go into botany or you go into forestry, you look at sedge. Sedge looks like that grass, but it's not a grass. It's a native sedge that we have in the state. But it also, how many of you are familiar with the relationship with fungus and the soil? So when you go out and you see the mushrooms popping up, those fairy rings popping up, do you think that's a good thing? You have your DNR mushroom poster right there, your fungus poster. Is fungus a good thing? Fungus is an excellent thing. So when you see fungus, that's an indicator. When I see sedge, it's an indicator. It tells me immediately that a worm front has gone through the forest and something has happened to that soil, and that fungal relationship is depleted. Something's happening there. Because when you look at plants and you look at native plants, 95% of all of our native plants are bound to a mutualistic relationship with fungus. So when we have our other 5% plants that aren't bound to this mutualistic relationship with fungus, they come in and they take over. Because the fungus has been removed from the soil, it's depleted. And you get sedge. And sedge, does anyone know what's in sedge? Silica. So it has a silica component, so the earthworms underneath the sedge can't feed on that roots because it has that silica sandy component to it, so it rips them up so they stay away from the sedge. So when you walk into a forest and you're looking for worms, don't look in that sedge because they're trying to stay away from the sedge. This is a worm front moving through a recreational area. So it's dominating the recreational campground. Because remember, wherever we go, we introduce things with us. So people have gone to this campground, this is up in Trout Lake, and they've gone there for years and years and years. They're on Trout Lake, so they have their worms, they're done fishing, they toss them out in the woods because they always thought, well, that's a great thing to do. It's created a monoculture in this particular area. And if I were looking for worms in this area, where would I look for them? Would I look in the sedge, or would I look in here? There's some trout
In there.
lilies. You would look in here, so they're concentrated in here. This is where they are, and the really interesting thing about them, in order to stay away from that sedge, they'll cross roads. So sometimes you can go into a forest in like the Nicolay, Schwamigan forest up north, and you can actually see how worms have crossed over the road in order to get away from that sedge, because there's no nutrients for them. They have to stay away from it. This is a worm front, so when you walk into the woods, you spend a lot of time outdoors, like I do, you'll notice things moving through the forest. So this is a 10-year study so far. I would imagine I'm going to get more regeneration in the next 5 years in the back. But I've been watching this front, and currently this year, I'm way beyond this tree. So the sedge is past here, and the worms keep moving. And when you get a lot of sedge moving in your forest, you start to lose what? If you are an acorn or a maple samara and you fell, you need to get to that soil, right? Can you get to that soil through the sedge? No, so it's almost impenetrable. So you lose regeneration. So you lose regeneration of your forest. So then you have forest problems. You also lose small mammals. So we have a lot of mammals that live on the forest floor, and you start to see declines in them as well. Why is this happening? Anyone want to take a guess? Well, there's lots of different things that play into it. And every year I spend researching earthworms and working for the DNR, going all around the state. Each year my hypothesis of what's happening changes, because I see new things happening on the landscape every single year. And so I'll have one theory one year and one theory the next year, and I know it's going to change the following year. Sedge creates a monoculture. Sedge is a big problem for foresters, the Forest Service, the DNR, because we're not getting any regeneration to stand. And whether that's because we are opening up the canopies, there's more year in there, we just don't know. We know that it's all interconnected, but we can't pinpoint it directly. So when I take this slide, do you see something missing? So when I work with landowners, I always ask them, well, what's it look like underneath your trees? So you're missing that component of your leaf litter, and you always want that leaf litter to be at least 3 to 5 inches. Ideally, you want it to be about 6 to 8. You want to see that because it's protecting the soil. Always think of leaves as like a skin breathing for the soil. When you start to lose that protection of the leaves, you start to see declines and erosion occurring, and then your soil becomes depleted and it opens it up for other species to come and take that place. The mycelium, and that's what I'm talking about with the fungal relationship, is huge. When you're in a forest, you always want to see fungus. You want to move that leaf litter, and if you've ever picked up those wet leaves and it looks like there's this fungus in there, it looks like white, and you don't know what it is, and a lot of people, even my husband, drops it and said, ugh. That's what you want to see, because it's really important for the regeneration. And when I look at a forest, and I'll use sugar maple as my example, when the samara falls from the sugar maple tree, it needs to fall into the leaf litter, and it needs to be protected in that leaf litter with the mycelium, with the hypha, with all of these fungal relationships in there. And then it has to germinate right at 32, 33 degrees. And if that doesn't occur, you won't have regeneration of that particular species. So it's almost like a canary in the coal mine when you're looking at the health of the forest. I always look at sugar maples as one good example. This is mycelium. So these are the bands of mycelium, the hypha, and it's really important to see them. So when you're looking at your leaf litter, particularly in a forest, in a natural setting, this is great. This is what you want to see. But what about the presence of other invasive species? Can you think of other invasive species in the state that are having an effect, that might have a relationship with earthworms and everything else? Are any of you going somewhere this weekend? Where are you going? Exactly. So deer have a huge role in the spread of invasive species. They have a huge role in the spread of earthworms. And so a lot of times you'll see, how many of you are familiar with buckthorn? Okay, so buckthorn. Alright, one of my favorite plants. So buckthorn, garlic mustard, deer, earthworms, and you know buckthorn and garlic mustard, they all have that alleliopath, so they release that chemical in the soil, which inhibits the growth of everything else there except that species. So when you go out into a stand and you have a heavy infestation of earthworms, you see huge decline, you see deer browse, you see buckthorn, you see garlic mustard. You think I'll see earthworms in there? I will, because it's all of this cycling, so it creates a cascading effect. When you get one, you get the other, you get another, and you keep getting another. So all of these things go hand in hand, and at the DNR we have the Deer Czar report. And you know, I have a theory about hunters, because I spend a lot of time hiking through the woods, and they always tell me, oh, did you see any deer when you were in there? And I said, of course, I saw lots of deer in there. You have to walk, and you have to hike, and you actually have to hunt. You can't just sit in your car, in your stand, in your pile. You have to hike into the woods and hunt. So, I never said that, and it goes back to the DNR. You'll back me up on that, right, Shannon? Okay, so that's my theory. You have to actually do the work to get the deer. And I could never shoot a deer. You know, I could never do it. I'd probably have a nervous breakdown if I did. But I tell everybody else, shoot the deer, because there are way too many deer in the state. There's just way too many of them, and when you're out there and you're surveying, you see them all the time. And you know, when you have a bigger herd, you see declines and all these other things out there. Okay, so I never said any of that in our employee, just scratch that from your memory. Okay, so buckthorn. When I look at buckthorn and earthworms, they have a huge component together. So this is the UW Arboretum, which we refer to as the Arboretum invasive arboretum, because everything there is, they're managing for invasives. So this is one huge side of buckthorn, and then the other side is a control plot that they get. If you were a guessing individual, where do you think the earthworms would be? Okay, so we nuked this with Garland, We nuked this with Garland 4. They went back. Have any of you done herbicide treatments yet?